Welcome back, everybody. This is going to be the second and final part in my series on the Cartesian coordinate system. If you haven't checked out my last video, please go and watch that now, as it's going to have some vocab and stuff like that that's going to be really important for your understanding in this video. In this video, I hope to show you how to graph a couple more complicated things more procedurally. Let's get started. Before we can graph more complicated things, we have to understand what more complicated things look like. And we've seen some of these already, just without this lens or this context, in the previous videos. An equation in two variables is some relationship between two expressions with two different variables. A particular pair of values that satisfy that relationship are called a solution to the equation, in case you were ever wondering what a solution actually even is. So in this example, all I want to do is show that 1, 3 is a solution to this equation in two variables. Notice that these are two algebraic expressions of different variables being set equal to each other. How do I do that? Well, we learned from the last video that in an ordered pair, x is the first number and y is the second number. So what I am asking you to do here really is to plug in those values of x and y and see if you actually do get the same thing on both sides. On the right side of the equation, that's a little bit more complicated. I've got 4 minus x, which happens to be 1 for this point, squared. And on the left-hand side, it's pretty straightforward. Just y, or 3. Simplifying that right-hand side, I get 4 minus 1, and sure enough, 3 does equal 3. So 1, 3 is a solution to this equation. We can use this idea to help us sketch the graph of this equation, because thinking about it as a graph instead of an equation is sometimes a little bit more helpful of a context, as it helps us to visualize the relationship between these numbers. We can think about x as being the input and y as being the output. So on the left side, I've made a little table of x and y. And I've got a few inputs to try, and I want to measure what the outputs are going to be. When I plug in -2, I get 4 minus -2 squared, which is going to be 4 minus 4, or 0. So what this tells me is the point 4, 0 is on the graph. Excuse me. The point -2, 0 is on the graph. Just said 4 so many times it felt like I should say it again. So let's plot it. I go over 2 to the left to find -2 on the x-axis, and I move nowhere vertically. That's where the point -2, 0 falls. Why don't you pause the video here and see if you can find the output value for all of the other x values in this table as the next 4 outputs to this function. That tells me that these 4 points also reside on the function. -1, 3, 0, 4, 1, 3, and 2, 0 are all on this function. Now we can actually sketch its graph by connecting the dots. And I get this upside down U shape here, which this shape actually has a fancy name. We call this shape a parabola. That's going to do it for this series on the Cartesian coordinate system. From this video, I hope that you learned how to look at equations of two variables as having an input-output relationship, and how visualizing them in the Cartesian coordinate system can be valuable. Catch y'all in the next one.